Hola! So today we will be talking about the encoding and decoding of matrices. First off, the formula for encoded message, which is x is equals to the message multiplied to the encoding matrix, or A. Alongside this, we also have the decoded message, which is y is equals to x, which is the encoded message multiplied to the inverse of the encoding matrix. Of course, if we are going to encode and decode a message, we will be needing the character key, starting off with the space sign to the alphabets and two special characters from number 0 to 28. For this session, we will be having our first example as Sir Salamat. Also given is the encoding matrix, or the A. To start off, we will convert or translate the message into numerical characters. After the message is translated into numerical characters, we'll be dividing or grouping the numbers into three, for we will be creating a matrix which has three columns. To translate the message into numerical characters, you can simply look for the corresponding number to the corresponding letter on the character key. Then we added two zeros at the end of the numbers because we will be needing to fill the gap to complete the group of three. Moving on, we will now start to encode the message by multiplying the translated numerical matrix to the encoding matrix. We will be doing this by multiplying the first row of the message to the first column of the encoding matrix. This is only for the first column. When we proceed to the second column of our encoded message, we will be using again per row of the first matrix, but then we will be multiplying the values of the second column found in the encoding matrix. So we'll just continue that until we finish all the values found in the first column. So here is the finished matrix. But I will still show you how to do the second column of our encoded message. So to start off, again, we'll take the values from the first row of the first matrix, which is the translated message. Then we will multiply it to the second column found in the encoding matrix. Just so. We will keep on doing this until we finish all the values found on the rows found on the translated message. So yes, and then we'll continue this until the end. Moving on to the third column, we'll still be doing the same procedure, but moving on to the third column of the encoding matrix. So all the rows found on the translated message again multiply to the values found on the third column. So just to make it clear, when we multiply with the first number from the row, then the first number from the column, and the second number from the row multiplied to the second number from the column. Okay, I hope I'm making sense right now. Until we finish the whole matrix. Moving on, we have completed the encoded message, so we have something to use for the decoding. So y is equals to x, which is the translated or the encoded message, multiplied to the inverse of the encoding matrix. Now we don't have the value of the inverse of the encoding matrix. We'll be first doing that. We'll be finding the value of the inverse of our encoding matrix. So start off, we'll be getting the minor of the encoding matrix, then the cofactor, then the transpose, and lastly the determinant of the encoding matrix. So here's how to get the minor of the encoding matrix. Let's get back to the given. So here we will be getting the first point, which is from the number 2. We'll be cancelling the row and the column which it belongs to. Then the remaining 4 numbers, we'll be getting the determinant of those, and that will be the first point. So on and so forth. So when getting the next value, for example, in the negative 3, we'll be cancelling the column and the row which it belongs to. Then the remaining 4 digits, we'll be getting the determinant of those, and that will be the value of our point. Until we finish the whole matrix. After we have solved for the minor of A, then we'll be able to get easily the cofactor of it. So we'll just change the signs from positive, negative, positive, then negative, positive, negative, then positive, negative, positive. We'll be just multiplying these signs to the matrix of the minor of A. After getting all those, now we can now get the transpose of A. We'll just simply transfer the first row of the cofactor of A to be the first column of our transpose of A. Now that we are now able to decode the message or crack the message at last. Just like we have done in the encoding, we'll be multiplying rows for the translated one, then to the first column or per column of the encoding or the encoding matrix. Then this time the difference is we'll be dividing it by the determinant of the encoding matrix, just like so. So we started with the first row and the first column. 65 multiplied to negative 22 plus 99 multiplied to 6 plus 19 multiplied to negative 18 all over negative 62. So I'll show you in the calcul, of course. So 65 again multiplied to negative 22 plus 99 multiplied to 6 plus 19 multiplied to negative 18 all over 62, which equals to 19. Oh, I was advanced. Yes, so that is the first value in our matrix. As you can see, if we compare it to the first one, if we complete it, we'll be getting the exact matrix. If we didn't have any error, you are not supposed to get any decimal point here. You must only get whole numbers, for whole numbers are only the ones that correspond to a character key. Now that we have completed the matrix, we are now able to crack the message at last. Again, we will write it down from left to right, left to right, left to right. After writing all down the values, we are now done.